Right, we're in our final partial derivative chain rule example. If you are finding this series helpful, please let me know down below and subscribe to the channel. We'll get right into today's result, which is that if we have u as some function of x and y, but x and y themselves are both functions of three variables, alpha, beta, gamma, and as I said, the same for y. So y is also its own function, a different function to x, but of the same three variables. So what does this change? We've already discussed that when we have, because we're differentiating u and we want to differentiate with respect to alpha, beta and gamma, our extra variables. So because u is a function of two variables, there's still two terms to our partial derivatives, but the only difference here is u is a function of x and y, and x and y are a function of three variables. So all that happens is we now have three different variables we can partially differentiate u with respect to. It just gives us an extra result. It doesn't change any of the patterns that we had before. So du by the alpha, a partial du by the alpha is partial du dx, partial dx d alpha plus partial du dy, partial dy d alpha. Okay, so that's a familiar pattern that you should be remembering now. Number of variables gives you the number of terms. Du beta is partial du dx by partial dx d beta plus partial du dy partial dy d beta, and then finally we can differentiate u partially with respect to gamma, and that's partial du dx, terrible x, but anyway, partial dx d gamma plus partial dy, partial du, getting ahead of myself, dy, partial dy d gamma. Okay, so those are our three chain rules we get from this setup. Hopefully if you've watched all four of these videos, you understand how to form these yourself for various different cases, perhaps in 4, 5, 6 variables, so the pattern always remains the same. If you did enjoy this video, please like and subscribe, and I hope to see you in the next one.